Hello, hope you're doing well. In this video, I'm going to start a series that will deal with measures of association. We'll talk about several different measures of association, several different methods, several different techniques, and we will also talk about a simple linear regression, which is built upon some of the simpler measures of correlation. And there will be several videos. I believe I'm going to end up with about 7 videos in this series, and these videos will be numbered from 1 through 7 or 1 through 8, and you need to watch them in numerical order. These videos are primarily intended for my students in business statistics at Northeastern State University, but there is also application or usefulness for safety management professionals. Several of these techniques do show up on certification exams periodically, but more importantly than the certification exams, these methods can be used by safety managers to better understand the association between two variables. And that's really what we're talking about with measures of association, the association between two or more variables. We'll mostly be focusing on two variable relationships, but I'll also show you a technique called partial correlation that can be used to assess the effect of a third variable on the relationship between the other two variables. And it can go on beyond there. You can have multiple correlation. You can assess the relationship between two variables while controlling for the effect of 3, 4, 5 other variables if you wanted to, but we're not going that far in this video. That's more of an advanced statistics topic. It's not that difficult to understand or to calculate, but because of limited time, we're not going to go there. We're going to stop with what we call a first order partial correlation, and I'll get more into that when I cover partial correlation in its own video tutorial. But with correlation, we're looking at the measure of the relationship between two or more variables. I've already alluded to this. There are a number of different methods that can be used to assess relationships between variables, including methods for ordinal level data. And if you don't know what I mean by ordinal level data, go back in your textbook and review what we mean by ordinal level data. When I talk about the Spearman's row method, I'll say a little bit more about what we mean by ordinal level data. Pearson's R, or Pearson's correlation coefficient, is probably the most common measure of association that we should all be familiar with. Every human being should be familiar with Pearson's correlation coefficient. Because normally when we're reading an article in the newspaper or an academic journal and they talk about correlation between variables, they would have used Pearson's R to calculate that correlation value. Pearson's R is, of all the different methods we're going to talk about, I think the most important. Pearson's R also forms the foundation for simple linear regression, which can be used to make predictions about variables. We can predict variable Y based upon our data that we have for variable X. Again, more on that in its own video. The Pearson's R, and we'll have its own video. We'll talk in more detail about it and the method used for hand calculating that coefficient. Correlation is the basis for identifying causal relationships. I mean, that's like the holy grail of research. We want to know if X causes Y. And correlational methods are the starting point for identifying those causal relationships. But this isn't a very important point. Correlation alone does not prove a causal relationship. To conclude that a true causal relationship exists, there are 3 different criteria that must be met. We have to have correlation between the variables. We also have to have the proper time order of the variables. If X if we say that X causes Y, then X has to come before Y. If we can't establish that X comes before Y, we can't say that it's a causal relationship. Then the third general criteria for concluding that a causal relationship exists is that there aren't any other variables interfering in that relationship or affecting that relationship. Now, there may be a relationship between X and Y, but that relationship may be a spurious relationship caused by variable Z or variable A, B, C, D. There could be a lot of different variables that are affecting that relationship between X and Y. And when we talk about partial correlation, I'll talk more about spuriousness and methods that we have at our disposal to control the effect of third variables. I've already mentioned this. Correlation is used to calculate the beta weights that will go into our regression equation when we want to predict Y from our X values. Yeah, it has its own video coming up. This is just an overview, a preview of what we're dealing with in this particular series of videos. Now, these are the measures that we're going to cover in class when it comes to measures of association: Spearman's rho, non-parametric, ordinal level, which is a ranking strategy for measuring our variables, Pearson's R. It also goes by other names. Most common, most useful, as I've already mentioned, relationship between variables measured at the interval or ratio level. Partial correlation, a method to assess relationship between two variables while controlling for a third. Then we're also going to get into simple linear regression, and I will talk about multiple regression also. I'm not going to give you a lot of details on multiple regression, but I will mention it. Regression, the study of regression starts with simple linear regression, then it progresses to multiple regression. Then we also we'll talk a little bit about curvilinear relationships and curvilinear regression models, but not in a lot of detail. When we calculate correlation using Spearman's rho or Pearson's R, we're going to end up with a range of values from negative 1.0 to 1.0. Negative 1.0 is a perfect negative correlation, meaning that as one variable increases, the other variable value decreases. Positive 1.0, which is the highest our measures, our coefficients can be with these different methods, that means that as one variable increases, the other variable also increases. Again, the strength of the relationship is indicated by the absolute value. The direction of the relationship, whether it's positive or negative, is indicated by the sign. A negative sign out front means it's a negative relationship. Positive sign out front means it's a positive relationship. Has nothing to do with the strength of the relationship. And I don't mean to beat this up too much, but I see that as a common mistake. Students will sometimes think, well, it's negative 0.70, so that must be stronger than positive 0.39. Now, when you're talking about strength of the relationship, ignore the sign and just go by the absolute value. And below here, what we have here are some kind of unwritten rules for determining whether a correlation is significant or not. 0.2 to 0.39 would be considered a weak relationship, generally speaking. 0.40 to 0.69, a moderate relationship. 0.7 and above is generally considered a strong relationship. Now, if the absolute value is less than 0.2, in my opinion, that does not indicate any kind of significant relationship. But speaking in terms of significance, I'm not talking about statistical significance from a hypothesis testing standpoint. We can do hypothesis tests for our correlations. And with those hypothesis tests, we are testing the null hypothesis that the correlation is equal to 0. Our alternative hypothesis is that the correlation is not equal to 0. We're not really, that's very limited in what we can conclude with that type of hypothesis testing. But that's something to take note of. It's something that you'll see in printouts. We may even talk about statistical, or we may even talk about hypothesis testing for correlations before we're done with this series. All right, that's all I really wanted to talk about in this introductory video. Again, an introduction to this series. We're going to talk about identifying relationships between variables. That's an objective for many analyses that you will conduct or other researchers conduct, or that's commonly conducted in business. There are a variety of tools available. We'll talk about Spearman's Rho and Pearson's R, partial correlation, and simple linear regression. Again, watch these videos in this series in numerical order. And this is the coding system I'm going to use for the different videos. MA1, Measure of Association 1 is what that stands for. That's going to be the first video in the series. MA2, the second, and so on. Watch them in order or you're going to be lost. Also, you may be lost if you're not in business statistics and haven't studied all of the concepts that have led up to this series of videos. So if you're not in business statistics, you might want to go back and review my other videos. You might want to go back and review a good textbook in statistical analysis. If you are in business statistics and you're lost, we'll go back and watch the videos for sure and review in your textbook the different concepts that you can't recall from previous units. All right, that's it for this video. I will see you in the next video.